Alright guys, I'm going to go ahead and cover 7.5 multiplying a polynomial by a monomial. So basically you have a multiple terms expression, you times it by a single term expression. Okay. Before we start, I want to make sure you recall a couple things here, especially the distributive property. You know, remember how we distribute terms outside into each term inside. And for this particular section, it really helps, guys, to identify the terms, each term, by circling them. And you know, I want to introduce something called a containment structure. We'll talk about that in a minute. It's going to help you. It's just a way for us to help you organize your work. Okay, so it's really up to you as an option. Some of you might like it, some of you don't, so we'll see how that's going to work out. But let's go ahead and try this number up with together in this case. You have 5 times a squared, that's one term, it's a monomial, times it by negative 4a squared plus 2 times a, which is another term, minus 7. So you have a polynomial times it by a monomial. Okay, so what am I talking about when, go ahead and identify each term. This is what I mean. In this case, you have 3 terms. This is one term. Notice that when I circle the sign in front of the term as well, because the sign in front tells you what kind of term it is, whether it's the negative term or a positive term. So in here I have 3 terms, and when I say contained in structure, this is what I mean. It has 3 terms. So what you do is go ahead and draw in 3 boxes, 1 box for each term. Okay, you go ahead and bring down the monomial right here and place it right in the front. And then I hope you can recall what you did in science, that the Punnett square. If you don't, that's fine. But the idea is, whatever it is for each polynomial term, you are to multiply it with the monomial. Okay, so now you just go ahead and go in 5a squared times it by negative 4a squared. You know it's going to be negative 20a to the 4th power. Recall this, when we multiply powers with the same base, we add the powers, right? And then over here, 2a times 5a squared is going to give you 10. It's a positive, so make sure you put a plus sign there. Positive a to the 3rd power, and this is a negative 7 times 5a squared, which becomes negative 7a squared. You put them all together, that whatever in the box is your answer, so you end up with negative 20a to the 4th power plus 10a to the 3rd minus 7a squared. Very simple, very straightforward. It's really up to you. Okay, so I hope you catch a mistake that I just did here, because I did not distribute correctly. 5 times 7, negative 7 is negative 35. Okay, so go ahead and correct that mistake. It's negative 35. Okay. Now, what do I mean by distributing? If you are comfortable doing something like this, I certainly welcome you. I mean, you don't have to put it in a box format, but you know that every term will get that monomial distributed into each. So you can just go ahead and multiply each case. 5a squared times negative 4a squared, negative 20a to the 4th. Next term, 5a squared times 2a, that's a positive 10a to the 3rd. And the last one, 5a squared times negative 7, which becomes negative 35a squared. Notice that you get the same answer anyway. So it's really up to you, entirely up to you. The reason I really want to push for this kind of format is because when you get to a more complicated problem, it's a lot easier to have this structure set up, and you know that there has to be an answer going in there. And for some people, sometimes you might forget distributing to every single term. That's what I'm worried about. So try to use the structure as well, okay, the box structure. Let's take a look at another. Before you work on the next one, I really want you to try number 22 on page 392. Okay, make sure you work that problem out. It's 5x squared plus 2x minus 4, and the other side is to subtract x times 7x squared plus 2x minus the 3. Okay, so when you go ahead and use this box structure over here, that's going to give me 3 boxes because I have 3 terms inside. The 5x goes here, the positive 2x, and the negative 4. The 3 will go on the side outside, and I can start multiplying it in. 5 times 3x squared, 5 5x squared times 3, 15x squared, 3 times 2x, 6x, positive 6x. So make sure you put the positive negative as well. 3 times negative 4, negative 12. So my answer for that one, which is whatever inside the box here, 15x squared plus 6x minus 12. Okay, so that's my first polynomial after the distributive. Here, I know I have to subtract, right? Subtract what? X times whatever. So I can certainly go ahead and use the second technique, which is the distributive technique if you feel comfortable with it. Whatever you want, you can still use the box one. This is x times 7x to the second power, which is 7x to the third, x times 2x, which is 2x squared, and x times negative 3 is a negative 3x. So I take that, place it underneath here, but be careful, remember, from our previous lesson, we need to line the terms up. I have 7x to the third power here. This is x to the third column. I don't have it, so make sure I put it out here.
Kyle Besa, please report to the front office. Kyle Besa to the front office.
So as you can see here, since I don't have the 7x to the x to the third column, I make sure I put them in front of x squared because I want to line them up based on the degree of power. So I line them up. The 2x squared term is going to go next. The x term is going to go next. Okay, so what am I missing here in this case? I'm missing the x to the third column. I'm missing the constant column. Whatever I'm missing, I fill it in with a 0. This constant column, I just fill it in 0. For the x to the third column, I fill it in with a 0, x to the third. Okay, you see it? Space filler. And don't forget, we're subtracting, so the subtraction sign will now go in between. And if you need to be reminded that you need to be subtracting each column, it's okay to put in that minus sign in between. Okay, in between columns. So there you go. There you go. 0x to the third minus 7x to the third is going to get you negative 7x to the third. 15x squared minus 2x squared is going to get you 13x squared. It's a positive, so I remember to put the positive sign in front. 6x minus negative becomes positive, so it's going to become positive 9x squared, 9x. And negative 12 minus 0, which is still negative 12. So my final answer for this one is going to be negative 7x to the third plus 13x squared plus 9x minus 12. Okay, I want you to go ahead and try number 28 on page 392. Going to the last example, guys. Let's take a look at this one. This is something that can be done rather quickly. You have seen this before, and let's get this down. 2x times x plus 4 plus 7 equals to x plus 8 plus 2 times x plus 1 here plus 12. It's a long problem, but don't get intimidated by it because remember, we know the technique of distributing, right? We can certainly do that. So this now becomes 2x squared. Don't forget to distribute this to 4 as well, so it can become 8x plus 7. You cannot take the 2x and distribute it to 7 because the 7 does not belong in this group, okay? Same thing over here. The x plus 8 is another group of its own. You can go ahead and remove your parentheses in this case because there's nothing to distribute to. The 2x will be distributed to the x and 1, so you end up with 2x squared plus 2x. The 12 will not be distributed by the 2x because it's not in the same group again, so don't need to do anything with that. Next step, I try to combine like terms if I can. On the left-hand side, there's nothing to be combined. On the right-hand side, I notice I have the x terms, so I combine them together. I have the constant terms that I can combine, so I end up with 2x squared plus 3x plus 20. Notice that when you look at the term, you also look at the sign in front of term. This is 8x. This is positive 8, that's positive 12. So that's like how I get 20. This is positive x, that's just positive 2x, that's how I got 3x. And then, move the term over to combine as well. So I can subtract the 2x squared over. That will be canceled. You end up with 8x plus 7 equals to 3x plus 20. Subtract 3x both sides. You end up with 5x plus 7 equals to 20. Minus the 7 both sides. You have 5x equals to 13 divided by 5. X now is going to be 13 over 5 or 2 3/5. It's okay to have a fraction, guys. It's not wrong, you know, to get something that's not a whole number or whatever. So in this case, try number 40 on page 393, and we'll discuss this tomorrow. Okay?